Now, the third way of creating a vector is using an inbuilt function called linspace. So let's see what linspace does. So the linspace takes in 2 or 3 arguments. Arguments are the inputs you pass to the function. So the linspace creates linearly spaced. It generates a linearly spaced vector. Right. So this MATLAB function returns a row vector of evenly spaced points between x1 and x2. And you pass in x1 as the first argument or input, pass in x2 as the second argument. Right. So let's see how it is. Linspace 1, 10. So x1 is 1 and x2 is 10. But what linspace is going to do is it's going to give you a vector, a row vector, and the minimum of this, the smallest or first value is going to be 1, the last value is going to be 10. But it generates linearly spaced vectors. That means that between 10 and 1, by default, it's going to give you 100. Yes, 100 number of points. So you're going to have 100 elements in the row vector, and each of these elements will be evenly spaced from one another. So if I press enter, oops. If I press enter now, I'll get 100 numbers from 1 to 10 that are evenly spaced from one another. Right. So there's uniformity in their spacing. The interval here you can check out by subtracting any consecutive numbers. So 1.0909 minus 1 is 0.0909. So that is the interval, 0.0909. You add 0.0909 to 100 times and you'll get to 10. Okay, so that's what it means. So you have 100 points, 100 elements in this row vector by default, because that's how the linspace function works. Just passing the minimum and the maximum and to give you 100 elements, and you have even spacing between each of them. So let's do this with 1 and 100. Right, so between 1 and 100 the interval will be 1, and by default it will give you 100. So the interval has to be 1 for you to get up to 100. So you add from 1 to 100, you keep adding 1, you get to 100, and the total number of elements will be 100. Now the second way of calling the function, as we saw here, is by passing in 3 elements. Now you still pass in the minimum or the start and the end, but here now n will be the number of points that you want, so you can specify the number of points that you want exactly. So 1 to 100, and I want 50 points, let me say, instead of 100. So the interval now is going to change because you want 50 points from 1 to 100, right? So if it was 1 to 10 and I want just 10 numbers, the interval is going to be 1. If I wanted 20, the interval changed. This is now 0.4737. If I change this to, let's say, 0, it's going to be 0.5263, right? If I change this to 21, interval changes to 0.5. Okay. So how the linspace differs from using the colon operator is, when using the linspace, you can specify the number of points you want, and the interval will be computed automatically by the function. Whereas with the colon operator, you don't specify the number of points you want. Instead, you specify the interval between the elements. So here, and then the number of points will just be produced by default automatically. All right. So one last thing is the linspace. Linspace can also with the linspace you can specify a higher start higher initial number and a lower initial number, and you don't have to specify what the interval will be. So 20 and 1, this will give me 100 numbers between 20 and 1, and you'll notice immediately that the interval will be negative. Okay, so if we do this in space 100 to 0, not 0, 1, right? So we'll be going backwards, and our interval is negative. So you don't have to specify that the interval is going to be negative, because the linspace function will calculate the interval for you automatically. Right? All you need to do is specify if you want the number of points that will be inside the function. Sorry, inside the vector. Right? So that's the linspace function. So these are three ways that you can create vectors with. One, you can specify the elements in your vector directly. So you could use the colon operator, and then lastly you could use the linspace function and specify the number of elements that you want in your vector. So vector 1, 11, vector 2, vector 3. Yeah. So these three methods all produce row vectors, and if you needed to automatically convert from row to vector to column vector, you just add an apostrophe after the vector to indicate that you're transforming it, or you want the result of a column. You want the result to be a column vector. So that's that.